Morning, dear students. Welcome to this session on prestressed concrete subject. Last session we have talked about the property creep of concrete, where we have defined the creep of concrete, that the increase in deformation with the time under constant load. Okay, the parameters that it depends on, they're very similar to shrinkage, but there it is due to the exposure to environment, the property of shrinkage, whereas creep is from the load. Okay, that is the difference that you have to clearly understand, because both the parameters are same in both the cases, but whereas these creep parameters are from load. Okay, so under the action of load, expulsion of water from voids will be because of both the activity, maybe with the exposure to temperatures or even under load. Okay, so this is what we have talked about the last session. Also, we have seen the rate of loading, how it is going to create the creep, and we have defined creep coefficient, which is nothing but the ratio of ultimate creep strain to the elastic strain. Okay, and that values we have even tabulated the values for an estimated life period of 70 years, uh, okay, for the structures, for ordinary structural concrete, a lifetime expectation of 70 years is taken, and you can see that the ultimate strain values, I mean creep coefficient values, are given, which are ratios. Now, if you want the ultimate creep strain, you can just multiply this number ratio with the initial strain value. That will give you the ultimate creep strain value. That is the purpose of these numbers. Okay, so 7 days, you can see the number is 2.4 times, and the 28 days it is 1.8 times, and as you delay the number of days at loading, the value comes down, the creep coefficient value comes down, and the ultimate creep strain also reduces. Okay, so this is what we have talked about in the last session. In today's session, let us see what are all the formulas that you have for estimating creep strain value at a particular uh, time. Maybe, say for example, if you want the creep strain at 90 days, or else at 80 days, or else something like 6 months, you can estimate the creep strain values from the detailed expressions, mathematical expressions given by the IS code, which is in class 6 to 5. Okay, so 6 to 5 1 defines creep coefficient, as we have defined that the creep strain at a particular time divided by initial strain at loading. Okay, so generally for a particular member, the initial strain starts at loading, means in general we remove the shuttering whenever after remove shuttering, the load starts applied on the member. So whenever you remove the shuttering, uh, the self weight starts acting on it. So that point you can take it as initial point. Okay, time of loading. So that depends. Maybe after 7 days, or maybe after 14 days, or maybe after 28 days. How many days you take for curing of that particular member? Okay, right. So what code says is creep of concrete depends the factors in addition to listed in 6 to 4, which means the shrinkage, all the factors that shrinkage depends on, because both are almost similar. One refers to the load and another one refers to the exposure to the environment. Okay. So the other factors are stress in concrete, age at loading, and duration of loading. These three are additional parameters uh, in addition to 6 to 4. Okay. So as long as the stress in concrete doesn't exceed one third of characteristic compressive strength, that means FCK by 3. Okay. Creep may be assumed to be proportional to the stress. Okay. So if you just draw the stress diagram, stress versus creep value, okay, that will be linear in proportional to stress. This phi is proportional to the stress. Okay, that is the meaning of this. Okay, so this is given in IS code. If you keep open your IS codes, which is 6251, will give you the formula for creep coefficient definition. Similarly, the other, how do you estimate, that is definition part, how do you estimate phi value, the creep coefficient at a particular time is nothing but phi naught into beta, phi naught into beta. What is phi naught is a value which is given in the table where the notional creep coefficient to which the creep coefficient reaches with time, maybe 70 years, that the tabular form given. Okay, what about beta is coefficient describing development of creep with the time. Okay, so the phi value at any particular time, maybe after some days, if you want creep coefficient, you have to multiply the ultimate creep coefficient value with a factor. Okay, time factor. So how do you estimate those phi naught and beta? Only there is a tabular form available, that even that you can take, or else you have formulas to estimate both phi naught and beta. How do you estimate phi naught? Is this one. Phi RH relative humidity, beta FCM, beta T naught. Okay, so this is the relative humidity dependency, and this is strength dependency, the stress in the concrete, and this is time dependent parameter. Okay, so let us see how do you estimate these three terms so that to get phi naught value, and then we will see how to estimate beta also. Okay, so to get phi RH, which depends on relative humidity, the formula given to you depending on the strength of concrete. There are two formulas there. One which has FCK value less than or equal to 45, and if you have FCK more than 45 grade of concrete, the two different formulas given. Okay, so there the parameters involved are, you see, you need RH value, relative humidity, what percentage it is, 40, 50, 60, 70, 80, what number it is in terms of percentage, that you substitute here. And what is H naught? We have seen how to estimate H naught in the shrinkage parameter. The same formula holds good, and alpha 1, alpha 2 will be given expressions in the further slides, right? So relative humidity will be a number substitute here. So that's how you get phi RH. H naught, same formula, copied from that, 2 times area of cross section by perimeter, which is in contact with the atmosphere, okay, which is exposed to atmosphere in the other way. So cross section area AC. So 2 times AC by U is H naught, okay, notional size of the member, what we call it. Okay. Right. What is beta FCM? As I said, it is a factor to allow the concrete strength parameter, effect of strength on the creep coefficient. Okay. So that is given in terms of FCK. So the grade you substitute here, you get beta value. Similarly, the time factor, the factor which gives you to incorporate the effect of concrete age into that. So just substitute the t value uh, at which age you want this coefficient. Okay, t naught value will give you beta value, right? So this is about estimating phi naught value, ultimate creep coefficient. If you want to use an equation, otherwise you can use the table that is given in the class 6 to 5. Okay, that is what is said in this slide. So if the end results are not sensitive to precise values calculated as given above, means the strain value that you are going to calculate, if it is not sensitive to the precise values, if you don't want any precise value, means some work which is unimportant to you. Okay, for such cases, values given in table can be taken as final creep coefficient for design normal concretes of grades between M30 and M60. And for a condition where compressive stress doesn't exceed 0.36 FCK, one third of 0.33 around, so 0.36 FCK at the age of loading. And temperatures between 10 to 20 degree mean values. Seasonal variations shall be minus 22 plus 40. Okay. What happens if the temperature is greater than 40 degree? The coefficient shall be increased by 10%. Okay. So the value that is given in the table must be multiplied by 1.1, 10% extra. Okay. If the temperatures are more than 40 degrees. Okay. So this is the conditions to use those tabular values. So when to use equation to get phi naught value and when to use table. So if you need an accurate value, very precise value of phi naught, use this equation. Precise values, right? If you don't want a precise value, use the tabular value, satisfying all these conditions. Like concrete should be grade should be between M30 M60, and stress in the concrete is less than 0.36 FCK uh, at the age of loading. Okay, and the temperatures minus 22 plus 40. Okay, now that's about estimating ultimate creep strain. Right, if you want phi at a particular time, maybe at some say 400 days. Okay, at about 400 days, what is phi value if you want? The value phi naught is for the ultimate after 70 years. What will be the value to get ultimate creep strain? And if you want to estimate phi value at a particular time. This is the formula. Okay, so phi naught into beta, which is given earlier. So how do you estimate beta is given in this one, 6252 class. All these are available in the IS code. That's why I say you please refer to your IS code. Keep open your IS code. As I say the formula, you can just parallelly refer in your IS code. So it is like you want the quantities, like at what time you want this phi value, like I said 400 number of days, and T naught, the age of loading, where you start the age of loading, maybe 7 days or 28 days. Something like that. And beta H to estimate, and T and T naught holds good like that. So to estimate what is beta H, you have formulas again depending on the grade of concrete. Okay. So which depends on again humidity. H refers to humidity percentage. Okay. So likewise, you can estimate beta value. Again, the time variant and also the humidity variant, everything is involved in this beta. Whatever parameters it depends on. Okay. And you have the value of alpha 1, alpha 2 and alpha 3 required for calculations. So those are the strength influencing parameters. So those are given straight away in terms of formulas. So just you need to substitute FCK in all these things. Okay. So this is how you estimate if you want the ultimate creep strain or creep strain at a particular time. Okay. So this is about the estimation of creep value from IS code. Maybe to read a value from the table also. If the creep coefficient value that you want is not precise value that you don't want to have a precise value, right? Okay. So these formulas are all available in IS 1343 2012. Just go through all those formulas and what they are for and how to get those values, what to substitute, that you shall have the clarity. Okay. Otherwise, you don't, you will not be able to get a value. Okay. So RH, the relative humidity value at the time of estimation of phi, maybe say 400 days at such time, what is relative humidity you have, and RH naught is always a reference value which we take 100. Okay, so such is the case. So uh, maybe further we will go for deformation characteristics of the concrete in the next session. Okay. So this is the class on how to estimate the creep of concrete using codal formulas, or maybe reading a value from a tabular form given in the IS code. Right. Thank you.